Rosemary Ainslie, I've never before addressed you personally in these videos, even though I've made most of them for your benefit and solely for your benefit. But this time you have gone too far. I am so tired of doing your homework for you and refuting your silly and foolish assertions about this circuit that you don't understand in the least. But I'm going to do it this time, one more time, because you have finally taken the cake with your latest emissions of falsities and dumb claims. Alright? Now I've built the circuit on top of the circuit diagram, so even you should be able to see that the circuit is correctly built on the diagram. Here's the battery stack, 74.7 volts. These batteries are pretty well charged up. Here's where the battery positive comes in and connects to the load. Here's the other side of the load connected to the drain of the Q2 MOSFET and the drain of the Q1 MOSFET. Here's the gate of the Q1 MOSFET over to where I will be hooking up the red lead of the function generator. Here is the source of the Q2 MOSFETs to that same place. Here is the gate of the Q2 MOSFET going over here to the end of the current viewing resistor and also to the source of the Q1 MOSFET. Okay, there's the current viewing resistor of about 0.25 ohms, and that's the circuit. Right? Right? Are we agreed that I have constructed the circuit according to your diagram? Huh? Yes, I have. I'm only going to use one Q2 MOSFET though, because that's all you really need for this demonstration. Now I have a load there, and I have a thermometer on the load. It's calibrated in Fahrenheit. Right now it says about 105 or 104 degrees Fahrenheit, because I've already cooked this load a couple of times. See the black on there? Alright, and it's still warm. Okay, so now I'm going to go ahead and hook up the probes. Alright, here's the function generator red lead, goes to there. Here's the function generator black lead, goes to the common circuit ground point, as you always used in your demonstrations, in spite of the fact that that's not the correct place to put it. Here's the current sense probe. It goes to one end of the current viewing resistor, like that, and over to the common ground reference at the other end there. Here's the gate drive sense probe. It goes to the same place as the red function generator lead, and it's also connected to the common ground there. Alright, and now I'm ready to hook up the battery. Okay, there. Alright, so the circuit is now ready to run. You can see that I have a little bit of gate drive going right now. When I turn up the amplitude on the function generator, see all those Q2 oscillations? You can see that I get massive Q2 oscillations and then even Q1 oscillations that go completely off the screen up there. Okay, but let's put it right here with large Q2 oscillations, right? And the Q1s are just barely starting to lift there, right? Right? We have massive Q2 oscillations and a gate signal right there, right? Okay? And we have a little bit of load heating. We're up to 110 degrees now, okay? Now watch this. I've removed the Q1, right? And we still have massive Q2 oscillations. You see that? Massive Q2 oscillations with the Q1 missing. But that doesn't produce any heat in the load. It's not warming up anymore. I swear, I'm getting so tired of you, Ainslie. As you can see, I've removed the Q1 MOSFET. And I still get massive Q2 oscillations. You see that? That's at 2 volts per division. 2, 4, 6, 8, 10. So there's 10 or 12 volts drop across the current viewing resistor right now. The only possible return path for that current is through the function generator, and I'm not experiencing any difficulties at all with all that current indicated because it's not really going through the function generator. Okay, with the Q1 removed, as you can see, I still get massive Q2 oscillations, just as before. The Q1 transistor is irrelevant to the Q2 oscillations. It's not needed at all. There's no Q1 transistor in this circuit, just a Q2. I don't know why I bother. Now I've replaced the Q1 MOSFET. Notice the temperature on the thermometer. Sorry about the glare. It says 83, 84 degrees. Okay. Turn up the gate signal, and we get wonderful Q2 oscillations there. If I turn it up a little bit more, I actually get Q1 oscillations, just like in your demonstration, and then even more than that, a little bit more range there, even more than so here we go, Q1 oscillations, and then above that, now the Q1 is carrying lots of current, and the load temperature is rising. You see that? Huh? You see that? Now what I'm going to do is I'm going to cut the wire where I asked you to cut the wire, from the source of the Q2 MOSFET down to the function generator lead. It's cut. Where are your oscillations, Ainslie? They're gone. But the load is still heating because the current is going through the Q1 MOSFET now. You got that? I expect you to apologize to me